Good morning to all. Today we are going to see about types of laser. The outcome of this section or this topic, after completion of this section, the students able to understood the types of lasers. The lasers can be divided into gas laser, solid state lasers, liquid lasers, according to the active medium used, semiconductor lasers. First, let us see about the gas laser. The gas laser can be further classified into neutral atom, ion, and molecular lasers, whose the lasing medium are neutral atoms, ions, or gas molecules respectively. So it can be classified into helium neon lasers and carbon dioxide laser. First, let us see about the helium neon laser. The helium neon laser is a kind of neutral atom gas laser. The common wavelength of helium neon laser 632.8 nanometer. It's a tunable from infrared to various visible light frequency. Helium and neon are mixed according to a certain percentage. Pumping is by DC electrical discharge in the low pressure discharge tube. First, the helium atom is excited because of neon atom has an energy level very near to an energy level of helium. Through the kinetic interaction, the energy is readily transferred from helium to neon, and neon atom emits the desired laser light. The typical power of helium neon laser is below 500 megawatts is widely used for holography. The helium neon laser is kind of neutral atom gas laser. The common wavelength of helium neon laser is 632 nanometer. The typical power of helium neon laser is below 50 megawatts is widely used for holography, scanning, measurement, optical fiber communication, etc. It is usually most popular visible light laser. Next one is carbon dioxide laser. The carbon dioxide laser is a typical molecular gas laser. It emits a laser light at a wavelength of 10.6 mm. Its beam of power ranges from several watts to 25 kilowatts, even to 100 kilowatts. So, the CO2 laser is widely used in laser machining, welding, and surface treating. For this reason, the active medium CO2 laser is a mixture of CO2, helium, and nitrogen gases. The approximate constitute is CO2 is to N2 is to helium is equal to 0.8 is to 1 is to 7. The pumping is realized by AC or DC electrical discharge. First, most of the electrical discharge energy is absorbed by nitrogen gas only. A small part of energy is absorbed by CO2 molecules directly, which is raised from the ground state to upper state. Next one is solid laser. In solid state laser, ions is suspended in crystalline matrix to generate the laser light. The ion emits the electron when excited. The crystalline matrix spread the energy among the ions. The first solid state laser is ruby laser, but it is no longer used because of its lower frequency. Two common lasers are ND YAG laser and ND glass laser. The ND glass laser The glass rod has two advantages of growing into larger size YAG crystal, but the lower thermal conductivity of glass limits the pulse repetition of red ND glass laser. Next one is liquid laser. The liquid laser used the large organic dye molecules as the active lasing medium. These lasers can in a wide frequency range, that is, they frequency tunable. The spectral range of dyes covers infrared, visible, and ultraviolet. The pumping is by another pulsed continuous laser or pulse lump. These lasers are used in spectroscopic investigation and photochemical experiments. Last one is semiconductor laser. Is nothing but PN junction laser. A semiconductor laser is specially fabricated PN junction device which emits the coherent light when it is forward biased. It is made from gallium arsenide which is operated at lower temperature and emits a light in near IR region. Now the semiconductor lasers are also made to emit light almost the spectrum from UV to IR using different semiconductor material. It is made from gallium arsenide which is operated at low temperature and emits a light in near IR region. Now the semiconductor lasers are also made to emit light almost in the spectrum from UV to IR using different semiconductor materials. Now the semiconductor lasers are also made to emit light almost in the spectrum of UV to IR using different semiconductor materials. A p-type of region is formed on the n-type by doping zinc atom. The diode chip is about 500 micrometer long and 100 micrometer wide and thick. The top and bottom faces have metal contacts to pass the current.